Hey class, it's Mr. Chang. Let's talk about 5.4 solving exponential equations. I hope you guys all had a good long weekend and you're back at it, right? Ready to go again. So, just as a heads up, we are moving through exponential functions. And we already looked at the exponent laws and we did some work with that. But now this is solving exponential equations. It's basically not just an expression where you have to figure out what it equals, but I tell you what it equals. You have to tell me what the missing part was to make it equal. Yeah, that's kind of the idea. So let's go through it. It says here, the goal is to solve for the exponent in equations with unknown exponents. Okay, I'm going to give you an equation, and there's going to be an unknown, and that unknown is an exponent, so you have to figure out what it is. And there are steps to do it, okay? I don't want you to guess and check just by plugging in numbers to see what works, okay? That's not the point of the way we do it. That's not solving. That's just guess and check. Those of you guys who tried that on tests would realize that guess and check method will get you maybe 1 or 2 marks out of 5. It's not a successful way of going, okay? So here are the steps. What you want to do is to solve an unknown exponent. First, simplify the operations on both sides to have only one base. Okay, so there could be like other stuff tied into the base, like multiplying or dividing. And what you should do there is to do the opposite operations or reverse BEDMAS to get rid of that business. Okay, and once you do that, you're going to have an equation now where you only have just the one base on both sides, and then you want to make the bases the same. Okay, and when you make the bases the same, you want to think about what are some equivalent exponential expressions, okay, that will give you that very same number. Okay, so for instance, if there's an 8 there, that's the same thing as 2 to the exponent of 3. And you can substitute, instead of the 8, a 2 to the exponent 3 in there. Okay, so things like that. Next up, we're going to write the equation with only the exponents. And then we're going to solve for the unknown exponent by isolating with reverse BEDMAS. Once you get the hang of it, you'll see that it's actually pretty easy. You just have to spend a little bit of time just to watch my lesson and try it yourself. Okay? So question number 1 here says solve for the unknown variable. So you can see that the variable we're trying to identify is an exponent. So this is an exponential equation. Okay, and to solve for it, first off, simplify operations on both sides to have one base. Okay, we have one base. We've got a 2 here and we've got a 16. So first step is done. Make the bases the same. Well, this is 2 to the exponent x, and this is 16. So you're going to look at the 16 and you're going to think, is this 2 to the exponent something? Because if it is, then I can write it as 2 to the exponent something, and then I'll have the same basis. And 16 is actually equal to 2 to the exponent of 4. Okay? And 2 to the exponent 4 is the same thing as 16. That's 2 times 2, which is 4, times 2 again, which is 8, times 2 again, which is 16. And we're going to substitute 2 to the exponent 4 into it. So here we go. Let's write the equation again. 2 to the exponent x, that's the left side. On the right side, I'm going to plug in 2 to the exponent 4. All right. Third step says, now that you've got the bases the same, you want to write the equation with only the exponents. So the bases are the same. I can come in and do the third step and just write x is equal to 4. Since the bases are the same, well, then the exponents will have to be the same. Okay, so it's a matter of seeing if, this is already isolated. If it is, well, you're done. If it isn't, then you're going to have to figure it out. So in this case, it is done. There's nothing I need to move around or anything to solve for, in step 4, the unknown exponent. So we're done. Okay, and you can even plug in a 4 up here and see what it works out to be. Okay, let's go with the next one. 5 to the exponent 2x is equal to 625. So right off the bat, I'm thinking 625 and 5. 5. I wonder if 625 is 5 to the exponent anything, and I'm going to attach a table, and you guys can look at that table. 625 is actually 5 to the exponent 4, because 5 times 5 is 25, times 5 again will be 125, and times 5 one more time would give you 5 to the exponent 4, which is 625. So we're going to come in here, and we're going to sub in 5 to the exponent 4, and that'll take the spot of 625. Okay, now we got the same bases, so let's just deal with the exponents. That's a 4. And now all we have to do is step 4 here. We just have to solve for the unknown exponent by isolating with reverse bedmass. So 2x is equal to 4. It's easy. Let's just divide out the 2. So we can get the x by itself. And x is equal to 2. Okay, so what does that check look like? You know, just for interest's sake, if you wanted to do a check on the left side and the right side, well, the left side is 5 to the exponent 2x, and the right side is 625. You just take the original equation and try the check right there. Okay, that's really what it is. Oh, wow, what did I do there? Okay, 625. So what you got to come in and do is just sub in that 5. This is 5 to the exponent 2, and x now is 2. Okay, is equal to 625, which I will not need to keep on writing. That's the same as 5 to the exponent 4. Okay, and all these are equal. And guess what? 625. Okay, therefore, left side is equal to the right side. Right, these are all the same. Good? All right. Let's keep it going with this 2 to the exponent 25x plus 1 is equal to 250. So I think step 1 is now being a part here, okay? Because remember, step 1 said, let me scroll back up, simplify the operations on both sides to have only one base. And the tip was to use reverse bedmass. See, the problem is I don't just have the one base. I have 2 times the 25x plus 1. So I need to write it with just the one base. So I'm going to get rid of the multiplying by 2. Okay, so right now this is multiplying by 2. To do the opposite of multiplying by 2, it'd be dividing by 2 on both sides. And this will give me my new answer, which is 25x plus 1 is equal to 125. Okay, now in fact, because I got rid of the multiplying situation with the 2, I can get rid of the brackets. These are the same. Okay, all right. Second step is you need to write both sides of the equation with the same base. So, you know, I'm looking at 25 and 125, and 25 is 25 to the exponent anything. 125, 25 to the exponent 2 is already past 125. And so, you know, unfortunately, I can't use 25 or the 125. I have to try to think about something that they have in common. What is something that will multiply by itself to get to 25 and to 125? And the answer is we want to use 5, okay? And this really is 5 squared. That's 25, right? Don't forget the x plus 1, still in play, is equal to, and this is 5 cubed. Because 5 times 5 is 25, times 5 again will give you 125. Okay? And if you're freaking out because you're like, oh, you know, sir, you're doing all these exponents, you know, 5 times 5 and 5 times 5 times 5, how are we supposed to remember that 125 is 5 cubed? There's a table, you know, and I'm going to attach it after this lesson. You just open up that table, print it out, or have it in front of you, or just Google exponential table, and it'll give you, you know, what some of the common answers will be. Anyways, I got it all with the same thing. So, you know, we need to just now with the same base, we're going to write this out, right? So maybe I could take another step here, but this is 2 times the x plus 1, right? 2 times the x plus 1. So this is 2 times the x and 2 times the positive 1. So what's really going on here is I'm going to write it like this. They need to multiply. Okay, and we're going to go ahead and solve for the 3, for the x. So let's go in, 2x plus 2 is equal to 3. Let's send the 2 to this side. And let's get 2x is equal to 3 subtract 2. 2x is equal to 1. And let's bring it home by dividing out that 2. And we're going to get x is equal to 1/2. Boom. Okay. That's the answer. Let's keep it going. The next one I want to talk about is right here. It says 5 to the exponent 2x plus 2 is equal to 1 over 625. So let's see if we can tackle this nice and quick. Again, 625, this is a product of 5 times 5 times 5 is 5 to the power of something. And the answer here is 5 to the power of 4. So let's figure out what this is, okay? I'm going to come in and say 5 to the exponent 2x plus 2 is equal to 1 over 5 to the power of 4. Okay, and if you guys remember, this is 5 to the power of 4, but it's a reciprocal. There should be something that's triggering here. Some of you guys hopefully will be able to spot it. We are actually talking about this 5 to the exponent negative 4. That's a negative exponent. Okay, now we got the same base. Let's just work with the exponents, and this will be 2x plus 2 is equal to negative 4. And let's send the 2 up on the other side. And we'll get 2x is equal to negative 4 subtract 2, or 2x is equal to negative 6. And let's bring it home by dividing out the 2 again. And we're going to say x is equal to negative 3. Done. Okay, hope you guys are picking up on the main idea here. Just trying to isolate that exponent up on the top. All right, let's try something a little bit more complicated here. 6 to the exponent 8 divided by 6 to the exponent negative 2 to the exponent 5 is equal to 6 to the exponent 9x plus 2. I like how we have, like, the same base across, so that sounds like a very positive thing. But what can we do on the left side first? Okay, so let's just deal with this first. This will give us 6 to the exponent 8 is equal to 6 to the exponent negative 10 is equal to 6 to the exponent 9x plus 2. Next up, well, this is 8 subtract negative 10, right? That's the quotient rule. So what can we do with the quotient rule? 8 subtract negative 10, this will give us 6 to the exponent 8 subtract, just in case people can't see it, looks like this. Of course, that's 6 to the exponent 8 plus 10, that gives us 18, is equal to 6 to the exponent 9x plus 2. Okay, and we got to stage 3, and I'm just going to pause it for a second so you guys can figure out what. Did you get this answer? X is equal to 16 over 9. Okay, so some of you guys are like, well, how am I going to check this? Well, the worksheet I'm going to give you will have the answers on the bottom, but if you're like, how are you going to check it in a more productive way? You can actually plug in that the x value is 16 over 9 up on the top and try to work it out. Like on the top, I could tell you on the right side, on the left side, right? Let's just do this real quick just for interest's sake. On the left side, this was 6 to the exponent 8 divided by 6 to the exponent negative 2 times 5. And we worked out that left side. That was actually 6 to the exponent 18. Right? And that was going to be massive. You can punch it in the calculator. I don't even know if that's going to be something that I'm too keen on finding out what that is. Yeah, that goes into scientific notation because we're going to have 1 and 14 digits after it. It's going to be very large. But on the right side, you can actually sub in 6 to the exponent 9 times, this is like 16 over 9, right? Plus 2. And you're like, what is that? 16 over 9 plus 2. Well, if you think about it, 9 and the 9, when you're multiplying by 9 and dividing by 9, guess what? They cross out, and you're left with 16 plus 2. And that is 6 to the exponent 18, buddy. And you get the same thing. Okay, left side equals right side. We just did our check. Left side equals right side. Okay, so there's your answer. Now, let's get to this. It says, here's a challenge question. I would like you to see if you can solve 4x. Okay, so here is the question. Let's see if you guys can earn the star. 36 to the exponent x plus 7 is equal to 1,296 to the exponent 3x plus 2. Now, you're thinking, okay, 1,296. I don't really know the exponentials to be able to get to 1,296. Well, don't look at that. Okay, let's look at what are some numbers that will square or cube to be able to get to 36. Okay, think about what those numbers are. Could it be 2s? Could it be 3s? Could it be 4s? And you'll see that 6 squared is 36. 6 cubed is 216. 6 to the exponent 4 is 1,296. Okay? I think that's all I need to take you up to. I'm going to pause it again, and I'm going to finish it. And I want you to finish it and see what you get. Okay? So when I say go ahead and pause it, and I'm going to reveal the answer. On your marks, get set, go! Bam! Did you get this? Okay, so let's figure out what we did here. First off, I wrote the bases to be the same, right? I substituted in 6 to the power of 2 or 6 to the power of 4, and that's the same as the 36 and the 1,296. All right, that's the same business, right? And once I did that, I've established the same base. So let's work with the exponents, and I've written out the exponents here. Okay, distributed in the 2 and the 4, and got this. And just collected the x's on the same side and the numbers on the other side, and isolated the x and got 3 over 5. Did you get 3 over 5? X is equal to 3 over 5. Looks fantastic. You did. Give yourself a nice pat on the back because you have now ascended to this level here where you are ready to do the practice. It says Rational Exponents Practice Worksheet. Again, have a look at the table of exponential values. That's going to be really good just to know and see some of those answers, and also try your hand at the worksheet. Fire off any questions to me during the week. Just going like, I don't get this, and I'll send you a video back or an audio if it's going to be easier, and tell you exactly what you're missing or whatever. Okay, so good luck and have a great week, everybody. Goodbye.